Hi there, my name is Dan Zentgraf. I'm Director of Solutions Architecture with a company called Liquibase based out of Austin, Texas in the US. And in this session, I'm going to talk to you a little bit about some of the lessons we can take from the DevOps movement and apply to managing internet scale schemas. Now, this is a pretty large topic, from both the DevOps side as well as the database side. So we're not going to get into too much detail, but I hope to introduce you to some concepts and ideas that you can investigate, learn from, and maybe apply to your own environments after this session. So to get this started, what we're going to do is talk about the challenges associated with schema management in a SQL database. A lot of them are the same that you'd see in a classic SQL database, just brought to a much larger extreme and a much more severe set of consequences if you get it wrong when you have a very large database distributed around the world. We're going to talk about balancing the challenges that come with schema management with the speed and safety that's implicit in DevOps practices. And then we'll look at a practical example of what I mean by speed and safety with some very simple examples at the very end. Hopefully we'll have some time for Q&A as well. All right, so let's take it back a step, right? One positive from 2020 we can say is that digital transformation became real and urgent for organizations. It went from being a strategic imperative that would happen eventually to something that we needed to deal with right here and right now. And we were lucky, right? If this had happened a few years ago, it would have been a lot harder. The technology and platforms that we have today and take for granted for delivering modern apps and all their functionality and putting those rapid feature changes out there really wouldn't have been there. In fact, you go back maybe 10 or 15 years and it would have been impractical for a lot of organizations to do what they have done just because the stuff wasn't available or it was simply too expensive at that time. And this applies to the databases as well, right? That's why we're at this conference, is because we have some of these new excellent platforms that we can leverage to deliver our applications. And that's really kind of part of the conversation. It's what brings us here to talk about the schemas, is that even as we talk about the great database platforms that we have, that we can build these giant databases and distribute them around the world, when we talk about changing them, managing them, putting the changes into them that are required to make features, actually work, we find that all of the techniques are application-centric. We don't really talk about what it means to do the same kind of updates at the same kind of cadence that happen at the app layer at the database schema layer. And a lot of that is due to the fact that schema changes are an inherently risky thing, right? If you think about it, it's a pretty complicated exercise. If you want to put a schema change into a pipeline of databases in a software delivery pipeline, you have to do it without, creating any kind of collisions among the changes. They all have to go in a certain order, and you don't want to break anything that's already in the database. You don't want to introduce a bug that causes the app to malfunction. You don't want to do anything that causes the data to come back wrong for the application or have some other kind of data-related error. You certainly don't want to degrade performance, or with some of the very large platforms, the efficiency, because though the performance will happen regardless of the efficiency, the bill for consuming the extra power will come in, and that's not a good thing. We also don't want to create security holes, of course, and obviously we never want to lose data. So we have to be able to apply these changes, deal with all of this complexity, while at the same time making sure that the lower environments where we're doing our integration and testing are actually in sync with production so that we know our test results are valid. We have to know when experimental changes go into one of the lower environments and eventually need to be removed, cleaned up. And we have to know the state of all of those databases, what changes are already in them, how far along the pipeline those changes have progressed, all that stuff at all times so that we can keep the team working effectively. And it's not that we don't have solutions for doing that today. We do. Classically, some organizations will throw bureaucracy at it, right? They put a lot of association with safety with many pairs of eyeballs looking at the changes. So we have a lot of review boards and meetings to check and recheck things. And hopefully with enough people looking at it, problems will be identified and avoided. And we can have plenty of tickets in our favorite ticketing system to make sure everybody knows what we're looking at. Another common approach is the app embedded script. So this is the idea that you put your database changes in your application code in order to drive those changes in. So every time you deploy the application, the code will apply any new database changes as needed. And that has the advantage of allowing changes to flow easily. They don't have to wait around while people have meetings about it. But at the same time, it often creates less transparency. It's harder for people to know what all is going in or how it is progressing through the pipeline. A lot of times you also get a lot less optimization in there. You get people who are not necessarily database experts making changes and applying them. And as a result, they may do things that are inefficient. They may do things that accidentally open up security holes just because they don't have the expertise or the depth of knowledge about the database platform. So you end up with something that usually works, but not always well. So you kind of trade speed and safety in the classic approaches. The DevOps movement was born at a time when application architectures were a lot more stateful than they are today. It was driven by practices identified by early adopters like Netflix and Google and Etsy and Amazon, folks who were building internet-scale applications back about 15 years ago. And those practices got identified and kind of coalesced into what we eventually came to call DevOps. And what we're really going to focus on is the change flow practices, and specifically continuous integration and continuous delivery, or frequently abbreviated as CI/CD. And this is a change flow practice inside of DevOps, and it tends to be central to most conversations. The other thing about it is while DevOps deals with a lot of principles that can be hard to adopt, CI/CD is a set of actual engineering practices that you can grab hold of, adopt, bring into your environment, and see benefit from. So we want to stay focused on them because at the end of the day, CI/CD emphasizes that flow with speed and safety and quality, and that makes it very valuable for what we want to do in the database space. So we're going to talk about 5 aspects of CI/CD in particular. Those are work in small batches, the idea that you should be always working with smaller groups of well-defined changes rather than a big group of changes. You need to be able to version everything, know what version of what file you're using at any time, what version of what database you're using at any time, and maintain that awareness for the entire team. We want to automate everything. Automation is always good. It takes a lot of manual labor and waiting out of a process. We want to test everything involved with delivering changes to the application so that we know that it works by the time it gets to production. And we want to have a way to shift things left, put quality checks as close to the change creation as possible, because at the end of the day, you can only build quality in. You can't test quality in. So drilling down into each of these very quickly, when we talk about working in small batches, this is the idea that your changes to any system should be well-defined, clearly bordered or bounded, and they should move in small groups of these well-bounded changes so that it's easy for everybody to understand what changes you're talking about, what the individual changes do. And the reason for that is that situation is easier to troubleshoot, right? If you've got 5 changes and one of them misbehaves, it's much easier to figure out which one as opposed to when you're dealing with 50 changes or 500 changes. And because they're well bounded, once you've identified which one's causing the problem, it's easier to isolate and contain that problem and ultimately correct the problem as well. Versioning everything goes with that. That whole notion of things being well bounded follows forward and says that you should always know exactly what you're working with, what that definition is at all times. Everybody should be able to easily see what version of the thing they're talking about. That's important because when everyone's looking at the same version of the exact same thing, they know what it is, they can know what to expect. If I apply these changes to one of our given target environments and that environment's at its specific version, I should know exactly what's going to happen at the far end. I can expect a result. And if I don't get that result, well, there's something wrong with the environment. If I think about it, if I've got a set of database changes and it works in one environment and it doesn't work in the other, well, that's a version file of database changes. It didn't change, so there's something up with the environment that wasn't where I expected it, and now I can act upon that. And that's crucial for enabling automation. Automation, we always talk about it in terms of speed because it's always going to be fast. The machine is fast, right? Machines are going to be faster than people. But it does 2 other things that are super important. First is that automation is always repeatable. The machine is always going to do the task the exact same way. That goes back to having a version of everything. I can have a version of my automation, and I will know what to expect from that automation every time, which means I can wrap tests around it. I can determine if the automation was successful or not automatically without a whole bunch of human review. The other thing it does is it eliminates wait time. Because I have things well automated, I can enable things to be self-service. So if somebody needs something done, they can essentially push a button and have the automation go and do that test. They don't have to wait for somebody to receive a ticket, act on it, ask questions, or whatever would happen in a human interaction. It's just going to go. One thing I would say about automation here that you need to keep in focus, a lot of times in DevOps we talk about automatically flowing changes from creation to production, and it all happens seamlessly and super fast. And that's great. If you can get to that point, that's awesome, but this is not that. What we're talking about here is the ability to bring automation into your process. And if maybe someday you get to the point where it flows end to end perfectly smooth, that's great. But we call that full end-to-end flow and auto promotion from environment to environment, continuous deployment, and that's beyond what we need to worry about here today. Fourth thing I want to talk about is testing everything. So we talked about having clear expectations for what each piece does in the pipeline so far. The reason for that, as you might have guessed, is that gives us the ability to understand how we should test it, how we should verify through automation and good engineering that when something is changed, we know that it has met expectations and can inspect that. And of course, we do that with application features all the time, but we also need to do that for our database changes and even the deployment process itself. Of course, we're concerned with the database changes. If when we deploy a database change to a particular environment, we should be testing the mechanism we use to deploy that change. We should use that same mechanism in all of our environments, whether it's an umbrella script or whatever. That is a part of our delivery process. It's a part of our application stack, really, and it should be tested just the same so that every time we do a deployment, every time we apply a database change, it's practice for applying that change eventually to production. Right? We want to rehearse our deployments to production in our lower environments. That's why we have lower environments. Anyways, to test, well, everything. Finally, shift left. So once we have the ability to manage these expectations through the pipeline, automate the flow, make sure that we are getting what we want when we move changes through our pipeline, we want to be sure that we have ways of making that pipeline efficient. We don't want to be moving junk through that pipeline. So we want to shift the quality checks left. How do we tell somebody who's creating a change that change is going to be good or not as quickly as we can? Literally right after they should be able to figure that out pretty much right after they've created the change. And this is related to the idea that it's always cheapest to identify bugs as close to development as possible. But in the case of a pipeline where you're changing something stateful like a database, this is also about safety. You know that any change that ever gets into the pipeline has at least met certain criteria. And this has all the benefits of, reducing rework, eliminating wasted test cycles, reduces the time developers have to wait for that feedback, and context switch. They worked on it 2 days ago and they don't really remember the details. It takes them a lot of time to get back in the mode. So these are all good, solid reasons for shifting that quality left as you go. So we're going to take a quick look now as we move into the demo environment. One of the ways you can do this, and I'm going to use Liquibase. And Liquibase's job is to bridge the gap between the application flows of CI/CD with the database change flows. And it allows you to do things like manage individual changes in what we call change sets, group the change sets into what we call changelog files, something that's easily versionable, something that you can surround the change sets with information on how the order in which they should run, tracking information and other metadata that tells you what you should expect from running them. And then the changelog files themselves become the versioned artifacts that you use to know specifically what batch of changes, well-defined changes, that you're running in any of your given target environments. And then Liquibase can be run in any automation system so that you can plug it in, drive automated checks before and after it as you need, and ensure that you get a consistent application of that small batch of well-defined changes into any of your given target environments, and you're doing it the same way every time in an automated fashion. All right, so I'm going to go ahead and jump into the demo environment here and take a look at a simple example, some of the concepts of what I mean. And here we are in the demo environment. Now, on the back end of the demo environment, I have a 3-node Yugabyte cluster on which I've put 3 databases to represent a dev environment, a QA environment, and a production environment. Now, given our time constraints, we probably are only going to look at 1 or 2 of those databases, but they're there so you'll know. What we really want to look at is how we're flowing changes into those databases and really through that simulated pipeline. And as I mentioned in the slides, we're going to talk a little bit about Liquibase and how we do that here. So as I mentioned, we have the concept of change logs and change sets. The file we're looking at right now is a changelog file. And as you can see inside of it, you have the ability to identify individual change sets within that file. So this creates that notion of a batch of changes, each of which is well defined in and of itself. As you can see here, they each have their own metadata, their own author information, identifying numbers, and even some other metadata. In this case, I put a simple label on them, but you can do a lot of other things as well. Okay, so this is the idea of working with small batches of well-defined changes. It's also in a file that has been checked into Git as its source control. The next thing we want to think about is automating everything. We want to automate how we're going to put this file into our environments. I'm using Jenkins as a basic automation system example, and we're going to go ahead and put these into our dev environment. So I can simply, using this tool, select the way I've got it configured, to select the dev environment, pick a version of the changelog file. In this case, I'm just going to use the latest. It's a demo, and we're kind of pressed for time. Normally, we'd maybe use a different version. Either way, it's off, it's running, and we're going to perform some basic checks before we put it into the environment. And it looks like we've got a problem. So we failed some of our verification. So back to the test, the principles. We've seen automate everything. Now we're seeing the results of test everything. And the fact that we've shifted those tests left, I get very immediate feedback as a change creator that there's something wrong. Right? These bad changes never got into my pipeline. It was caught right up front, and I was let know there's something up. And in this case, it looks like I've got some copy-paste leftovers here. I left in a identical number when I created these two examples. So I'll just take a number out of that one, check it into Git, stage it, commit it, push it, and now I've got a new version of that file in Git. Back to my repeatable automation, predictable results, and run it in here. So I'm going to go back through now with this new version of my batch running through my automated process, and it's going to go back through all the validations and make sure that the changes are in fact finally good as modified, or it's going to tell me to go fix something else. Already we're doing better than last time. At this point, we're past where we were last time, and the changes are indeed moving through and into the environment. Getting that test everything done there, we're going to validate that the deployment works and ultimately finalize the changes into the environment. Now, while it's doing that and the machines are doing what they do, we take another look at a little bit deeper functionality. So I've hooked this project up to what we call Liquibase Hub. It's a SaaS offering, software as a service offering in the cloud that you can sign up for, and it actually helps you track changes into your various environments that you're controlling with Liquibase. And this provides visibility and information for tracking what's going on. So I've got a list of the changes that are in the environment, got a whole list of them as we go, and I can go in and see the details of the operations being done. I can see what database they're talking to. I can see which changelog file we're going and the individual change sets that were in that changelog file. So I've got this nice overview of what's going on there and what the outcome of those operations actually were. And there's additional detailed data that you can go into. Currently got it because it's a demo environment forwarding all of the information, but you can control that to an extent so that only the information you want goes up to the Liquibase Hub. So kind of neat on the back end. Let's go and check in on our automation and see if that's done. And it is. We've now successfully deployed to our dev environment. And at this point, I can make some decisions. So there's probably some application tests. If this were a real environment, there are probably some application tests that would have to happen. Assuming those passed, I can go ahead and promote to the next environment using exactly the same process. And again, I've now been rehearsing this for production, right? I rehearsed it for QA and dev. I know that it works. Now I'm going to go and use this exact same process with the exact same version of the file, right, my batch of well-defined changes, and run this into QA using the exact same automation where I can know what I should expect, right? If something's not right, I will get notified, or if it's right, I should be able to predict the outcomes. And of course, all of this is happening left of production, and I'm shifting all of these checks and rehearsals earlier so that when I do get to production, I've mitigated any and all risk, or at least all the risks that I can when I do that. All right, so this is an example of how we use these 5 principles. It's very simple, but it illustrates all of the points. And using those 5 points, how you can achieve the speed and safety and quality that are promised by good CI/CD practices that we learned from the DevOps movement. All right, I hope that helped solidify some of the concepts that I was talking about in the slides. Obviously, we're going very quickly. We've got a limited amount of time together. If you're interested in learning more about this stuff, or you want to learn more about Liquibase, we've got a bunch of resources up at liquibase.org and a bunch of ways to connect with us. We're an open source project organization, so we've got a lot of different channels you can engage with us on, and we do have free learning classes available as well. So with that, I'm going to hand it back to our MC, and hopefully we've got time for a few questions.